Okay, pre-calc students, so we are still doing Unit 6, Day 2, and we started with the rational zeros theorem on page 1, and now we're going to write the equations of some polynomial functions, and we're going to start by using the number of zeros theorem, which says that the degree of the polynomial tells you how many zeros it can have at most. And the zeros might be complex zeros, or they might be imaginary zeros, or they might be rational zeros like we found with the rational roots theorem. So it tells you that every polynomial, A, B, and C here, they're all going to be of degree 3. And so they're going to all have 3 zeros. For A, it tells you each zero. And so remember, you can build a factor from a zero. You know that if 1 is the 0, the factor that would give you that 0 is x minus 1. Because if you set x minus 1 equal to 0, then you would get x equals 1 as your answer. And then if x is negative 1, then the factor that would give you that is x plus 1. And if you have a 0 of 5, the factor that would give you that 0 is x minus 5. Okay, so we want to write the polynomial function, so let's put an f of x in front. F of x equals, and now we have a polynomial function. Now sometimes you might be told that you can leave your function in factored form, but other times you might need to put this in standard form, and if you need to put it in standard form, then you can multiply. If you like to multiply with a box, you can feel free to do that. I just distribute, and so that's how I'm going to do it. You can multiply any two factors first. I'm going to multiply the first one and the second one here. So I have x times x and x times 1. So that gives me x squared plus 1x, negative 1 times x and negative 1 times 1, so minus 1x and minus 1. And I still have x minus 5, it didn't go anywhere. And then I notice that my middle two terms cancel out, which makes this a little bit simpler for distributing. X squared minus 1 times x minus 5. So I'm going to do the same thing, I'm going to multiply. X squared times x gives me x to the third. This gives me negative 5x squared, negative 1x, and positive 5. So here's my polynomial in standard form, and keep the f of x in front. Okay, so if you understood that pretty easily, you might want to try B before you continue with the video, and then check and see if you got it right. Okay, so let's start with an f of x equals, and it tells me negative 2 is a 0, and that means my factor is x plus 2. Now if the 0 has multiplicity of 3, that means my factor happens 3 times. So x plus 2, x plus 2, x plus 2. So again, I'm going to start with the first two. I'm going to multiply those. So f of x equals x squared plus 2x plus another 2x and plus 4. And bring down the last x plus 2. And then these two like terms combine, so I have x squared plus 4x plus 4, and then still times x plus 2. So I'm going to multiply again, and it's just a little bit longer because my polynomials are longer. I'm going to take that x and multiply it times the x squared times the x times the 4. So I get x to the third plus 4x squared plus 4x. And now I'm going to distribute the 2. So I have 2 times x squared, and that gives me 2x squared. And I'm just lining it up here because it's going to make it easier for me to combine like terms. And 2x times 4 is 8x. And 2 times 4 is 8. So now I'm going to combine my like terms. And I have f of x equals x to the third plus, this gives me 6x squared plus 12x and plus 8. All right, in the last one, they tell us the zeros, but here's something new. They tell us f of 1 equals 3. So I'm going to start with the zeros they gave me. I have f of x equals, and I have x plus 1, x minus 2, and x minus 4. Now what they're telling me here is that if I put 1 for the x, I'm going to get a y of 3. So I'm just going to test that out mentally here. If I put in 1 here, 1 plus 1 is 2, and then 1 minus 2 is negative 1, and 1 minus 4 is negative 3. When I multiply these, I don't get 3, so there's something missing from my equation. So I'm going to erase that. What's missing is an a value right here that would make this statement true. So I'm going to plug now 1 in for my x's, plug 3 in for my y, and see if I can solve for that a value. So 3 is my y, I don't know a, and I'm putting 1 in for all of my x's. So 1 plus 1, 1 minus 2, 1 minus 4. And a 2 times negative 1 times, oh, that was 1 minus 4, so that would be negative 3. Okay, so that gives me 6, so 3 is equal to 6a, and dividing it by 6, I get a equals a half. So now, if I put a 1/2 in here, I should have a true statement, f of 1 is equal to 3. So my answer is f of x equals 1/2 times x plus 1, x minus 2, x minus 4. And if I was asked for that in standard form, I could multiply all of this out, but for now I'm just going to leave this one in factored form. Okay, let's talk about the conjugate. The conjugate of a term is going to have the same first value and the opposite of the second value. We have talked about conjugates in trig. We talked about conjugates with roots and with i's, and it's going to happen in this case with imaginary numbers. So if I had something like 2 plus 5i, and I wanted the conjugate, it would be the same as the first term, 2, but it would be the opposite of the second term, minus 5i. If you have something that's a little bit easier, like say I just have 3i, you could think of the first term as 0. So 0 plus 3i, this would be 0 minus 3i, so just a negative. Okay, so if you have two parts, the conjugate is just going to be the same for the real part and the opposite for the imaginary part. And if it's just an imaginary part, then it would just be the opposite. The conjugate zeros theorem says that if a polynomial has one zero that's imaginary, the conjugate of that imaginary is also going to be a 0. And imaginary zeros always come in pairs. You can't have just one imaginary 0. If you think about the quadratic formula, when you solve the quadratic formula and you get an imaginary answer, that comes from the square root of a negative, and there's always a plus or minus. So the plus is creating one of your imaginary zeros, and the minus is creating the other imaginary 0. So let's see how that is important in this problem here. It tells us that we need a polynomial of lowest degree having only real coefficients, and these are going to be the zeros. And I know that if 2i is a 0, negative 2i is also a 0. So I'm just going to write it right here in the problem. The problem didn't mention it, but I know it's true, so I'm adding it in. So now I'm going to write the factors. X minus 3, x minus 2i, and x plus 2i. Now, when you write factors, you can't actually have imaginary numbers in your factors, but we're going to use these imaginary factors to build a real factor. So what I'm going to do is I'm going to multiply x times x, x times 2i. Notice it's the imaginary factors that I multiplied together. I left this one alone. So I have x squared plus 2i. Oh, that would be 2ix, sorry. And then I have a minus 2ix. And then I have a minus 4i squared. So these two middle terms cancel out, which is good. And I want you to remember that since I is the square root of -1, I squared is -1. So I'm going to substitute -1 for this one. These two cancel. So I have x minus 3 times x squared. Since I'm substituting -1 for I squared, I have -1 times -4, so this becomes plus 4 as my factor. And then, if I want to put this in standard form, I can distribute it. So I would have x to the third minus 3x squared plus 4x and minus 12. Okay, and this last one is harder. I'm going to help you out by getting you set up with the 0 and the factor, but then I want you to give it a try and see what you can do with that. So it tells us that 1 minus I is a 0. So the conjugate of 1 minus I is the same real term, 1, and then the opposite of the imaginary part, I. So it's 1 plus I. So when I'm writing factors from these, it would be x minus, and then in parentheses, 1 minus I times x plus, nope, x minus again. Sorry about that. Okay, so it's x minus, okay, so x minus 1 plus I. And we're going to distribute that, so I have x minus 1 plus I. The minus distributes to each of these, and I have x minus 1 minus I. Alright, so I have 3 terms times 3 terms, and that could be a good use of a box there if you want to multiply them with the box. Or you can just distribute 3 times. So I'll distribute the x first. X times x, x times minus 1, x times minus I. So I have x squared minus x minus xi. So that was x, x, x. Now I need to distribute the -1. -1 times x is -x. -1 times -1 is plus 1. And -1 times -I is plus I. So I'm trying to line up any like terms that I see. Now the I. So I have I times x, so that's going to be a plus xi. I times -1 is a -I. And I have I times -I, so -I squared. Now some of you may realize that's going to be a like term of something, but we haven't quite got there yet. Alright, so let's see what cancels. These two cancel, and these two cancel, and it looks like I have 2 negative x's, but let me just double check on that one. That's a -1, that's a -1, so that gives me -x, and that gives me -x. So I have x squared minus 2x plus 1 and minus I squared. Now remember, I squared is -1, so if I have minus -1, that's the same as plus 1. So plus 1 and plus 1 makes a plus 2. So this becomes x squared minus 2x plus 2. Okay, so now I know that this x squared minus 2x plus 2 is a factor of all of this. And so I'm going to actually do some long division to reduce this to a depressed polynomial that I can factor further. So I'm going to do I have space for this? I think I'll just make space. x squared minus 2x plus 2. And I'm dividing that into all of this. X to the 4 minus 7x to the 3 plus 18x squared minus 22x plus 12. So the first divided by the first. X to the 4th divided by x squared is x squared. Multiply x squared times all three terms and put the answer down here. So x to the 4 minus 2x to the 3 plus 2x squared. Subtract, oops. Okay, those cancel. Negative 7 minus negative 2 is negative 5. 18 minus 2, positive 16, and bring down the negative 22. Now we're doing negative 5x to the 3rd, the first term, divided by x squared. That gives you negative 5x, so that comes next over here. Multiply negative 5x times all three of these terms. So negative 5x to the 3rd plus 10x squared minus 10x. And subtract. So your first terms cancel. 16 minus 10 is 6. Negative 22 minus negative 10 is negative 22 plus 10. So negative 12x. And then bring down the plus 12. So I have 6x squared divided by x squared. That gives me plus 6. And then multiply 6 times all of these. So 6x squared minus 12x plus 12. So it divides evenly, which we expected. And I'm left with x squared minus 5x plus 6. So that I can factor. That's going to be, multiplies to 6 and adds to negative 5, x minus 2, x minus 3. Those are two factors. This is the third factor here. So let's see. The zeros they gave us this as a 0. They give us this as a 0. And then these two factors give us 2 more zeros. So let me just make a comprehensive list of zeros here. Zeros. And I have 1 minus I and 1 plus I. And then this factor gives me a 0 of 2, and this factor gives me a 0 of 3. So 4 zeros altogether. And then it says use the zeros to write the factored form of the equation, multiply the imaginary conjugates to find the real factor. So here's my real factor that came from my imaginary conjugates, x squared minus 2x plus 2. And then these are my other factors over here, x minus 2, x minus 3. And to make it an equation, we're going to put f of x equals in front. Okay, so that's the end of page 2.